will talk sort of about Kubernetes. I tricked you a little bit with the presentation title, but we will talk about distributed systems and open infrastructure and all those kind of things. Before I dive into my talk, just really briefly about myself. My name is Ildikó Váncsa. I work as Director of Community at the Open Infrastructure Foundation. In case you haven't heard of the foundation, we are a non-profit organization. We are supporting open source software development communities. OpenStack is our biggest and oldest project. It is an open source cloud platform. There's a good chance you heard about it already. The project is celebrating its 15th year anniversary this year, so it is a very exciting year for us, and we have a few other projects as well, and I will be talking about one of them today. As Director of Community within the foundation, I focus more on community management these days, both on the holistic level as well as being a community manager for two of our projects. Kata Containers is an open source container runtime. You may or may not have caught my talk on that 2 days ago. And the other one is StarlingX, which is a distributed cloud platform, and that one I will talk about today. But since I learned that sessions are 1 hour long at scale, I decided to start from a very, very high up bird's eye view and just touch on open source itself first a little bit and then zoom into the infrastructure side of things from there. So open source. Y'all are here, so you obviously heard of open source before. But what is interesting these days is somehow it feels like that sometimes we are taking open source for granted, even though open source seems to be present everywhere. Does anyone know or has a wild guess on like what percentage of modern digital infrastructure uses, depends on, integrates, or is entirely open source? Any guesses? 100% is one guess. Who? Sorry? More than 80. Any other opinions? No good or bad answers. I'm truly curious about, your perception and experience and opinion. Okay, so we landed on high numbers, over 80 up to 100. So I wanted to know what the world's perception was, as well as putting out some numbers. So I asked Google what Google thought. So I found the ZDNet article that said 78% of companies run open source software, so that's close to the 80 number. Then there is a report from, I believe, Linux Foundation Research. So they actually did look into it a little bit more closely, and they say that the estimated number is somewhere around 70 to 90%. So we are getting closer to that 100. And I also found a Gartner article report that says over 95% of IT enterprises across the entire globe use open source for their mission-critical IT workloads. But actually, it wasn't the number that caught my eye in this paragraph, but the last bit, which says whether they are aware of it or not, which kind of really nicely shows that open source is everywhere, but the awareness is not. And sort of recently-ish, this was fine, but we are reaching that stage when we are so dependent on open source that on one hand, we all have a responsibility, and on the other hand, we will be held accountable. On that note, governments are also recognizing open source. So on the value side, I am originally from Europe, even though I currently live in the US. I brought an example from Europe where the European Commission now has an open source strategy. The Commission has an open source program office, and they also have a strategy around open source, because they do recognize that open source is a fundamental foundational building block of modern digital infrastructure, as well as, well, digital life, I should say at this point, as well as recognizing the value of that, the openness part of open source, and sharing knowledge, software, applications, data, knowledge. So it is recognized, open source is now recognized up to the level of governments, and the European Commission is not the only one. Many governments around the globe are approaching open source from a regulatory perspective, but another example of a country and government who is embracing open source is Mexico, for example. So they have policies around specifically encouraging the use of open source and investing in open source software, and the government themselves decided to more strategically use and implement their own solutions within their government agencies and build their processes on open source, which I think is interesting and cool and a really great example to follow. And they have so far really good experience with it. Now, getting a little bit closer to where rubber hits the road, security/cybersecurity. That is an area that is getting really critical because most of us are living a very digital life. That means connectivity, our finances, healthcare, and we just depend on being connected almost 24 hours a day, 7 days a week, and yeah, the numbers just get worse. So when it comes to the perception of open source, I was also curious, what the world thinks about it, because when someone is not as familiar with what open source and open source software is and how open source communities operate, then it is kind of a wild guess out there when it comes to, how secure is open source code after all. So I asked Google, and at the time when I did, I think these were literally the first 3 hits and headlines that I got as the search result. So the first one, someone disagrees with the statement that open source is less secure because the vulnerabilities are also open and visible, but they have a struggle with figuring out how to make the argument to prove their point. The second one just flat out says that open source is inherently insecure, just don't trust it, don't touch it, even though we just discussed a few minutes ago that it is literally everywhere. So whether or not you want to, you're touching it every day. And then the third one says that it is more secure than closed source software. So you can see that when someone is not very familiar with the ecosystem and the projects and how all they are operating and how open source software is created, then the perception is just all over the place, which makes our life a little bit harder. Now, back to the government recognition side. Who has heard about the EU Cyber Resilience Act so far? One person a little bit, and otherwise it's rather a no. So that is kind of the other angle of the government's view on both the cybersecurity space as well as open source. So the EU Commission is working on trying to make the digital space a little bit safer and more secure. So that is what the EU Cyber Resilience Act is on a very high level about, which means that when something goes wrong, companies whose solution failed, they will be held liable. So there currently, the Cyber Resilience Act is already approved, and it is in place in Europe. However, they are still working on the exact details on what being compliant with the CRA means. But there was a phase where the CRA was really close to the point where there was a risk that individuals who are working on open source code will be liable for any bug in the code base that caused any kind of harm. Thankfully, we moved away from that stage by now. So they are currently working on things like what you need to report about your system and what that liability looks like. And it is recognized that many open source communities have stewards like open source foundations who will be shielding these communities from the effects of the CRA. But again, the liability part for commercial organizations, companies who are selling products, providing services, including open source software, they will be reliable, the open source bits and pieces from now on as well. So if anyone here works for a company that does business with Europe, be prepared for the CRA because it will affect you as well. Now, just making sure that I'm not running out of time too well, let's move forward and have the chat and conversation at the end. So let's take a look at open source infrastructure, because the infrastructure layer really is the place that we all depend on. It is usually not the place where you do differentiation and make the huge business. So that's not where your business value lies in most cases. So that is where having more open source components make more sense. So open source infrastructure, infrastructure that is built from building blocks that are open source meaning having a license that is OSI compatible and approved license, so not business source and I just say open, but my license doesn't really say so. And how it looks like in practice, you can now even have open hardware. If you go to the Open Compute project and check out their hardware specifications, you can build hardware yourself. You can put software infrastructure layer on top, Linux kernel, OpenStack, I mentioned it already, open source cloud platform, Kubernetes, container orchestration platform, all open source. And then the application space is where some are open, some are less, some are not. That is where the business value conversation kicks in even more. So if you are, for example, a vendor, an infrastructure provider, then actually relying on open source bits and pieces is what you want, so you don't get any vendor lock-in. I already mentioned the Mexican government, and funnily enough on the help desk versus community bullet point, I run a podcast on the side called My Open Source Experience, and I talked to someone from the Mexican government who's been working on rolling out those open source based solutions. And their experience was that investing in the community and project that they're relying on actually gave them better experience and results when they needed help compared to their experience with their commercial vendors. Just putting it out there in case someone needed to know and hear that. And when it comes to us as individuals, like just imagine that someone takes all open source code, software, and the whole concept away tomorrow. Like I would not want to live in that world where I don't have access to the shared knowledge, the shared software, the shared infrastructure, and not have the ability to work with others to evolve it. So, in practice, we reached the fun part. Today I will a little bit deeper into a project called StarlingX, which is an open source project. It is a fully integrated distributed cloud platform, so not just a cloud platform, but it is something that you can take and deploy it in a geographically distributed manner. So, what the project does, it integrates together well-known open source building blocks, and the community adds further components and services to it that you need in order to take the well-known open source components and deploy them again in a geographically distributed manner. And when it comes to use cases, the limit really is endless. The project is currently most utilized in the telecommunications segment, think about 5G workloads, but it is applicable in industrial automation and manufacturing, transportation, retail, and many, many other use cases as well. So when I say that you can deploy the project in a distributed deployment, what I meant is that you will have a central cloud with the control functions, and then you can have remote sites connected to it. And on the slide, you can see that those sites can vary in size from one server to 2 servers to multiple servers, and based on how much resources you have available, you can choose different configuration and deployment options with StarlingX. So what's inside that box? StarlingX started out the project was established in 2018, so 7 years ago, with integrating OpenStack and Kubernetes into one package, coupled with the Linux kernel and the Linux operating system. And since then, the community started to really embrace container technologies. So what that means is that when you deploy StarlingX, all of the system services and components will be deployed in containers. And when it comes to the structure of the project, on the platform infrastructure layer, Kubernetes and OpenStack components are both in use to run the main system infrastructure. And then on top of that, you can have container-only sites, and you can deploy OpenStack and have a full-blown OpenStack cloud, just like if it was an application, except that is sort of a complex, highly performing cloud platform. So it's pretty cool. And that also shows how versatile the project is. So not the extensive list of things that are inside and integrated in the StarlingX platform, but you do have access to a low latency Linux kernel. Currently, the project is integrating the Debian operating system. The community switched over from CentOS to Debian in the 8.0 release, which was a year and a half, 2 years ago, a little while ago now. And you can see that the diagram is pretty colorful from the back. Probably the little icons look rather black than purple. But in the rectangles, what you see is components that the project is integrating, and the little icons with the service names like host management, fault management, distributed cloud. Those are services and components that are designed, developed, and maintained by the StarlingX community. So that is kind of the added, I would say, secret sauce to create a distributed system, a geographically distributed system, but it is not secret because you have access to the documentation, the source code, the people who are working on it. So it's really hard to call it secret, but it is maybe a little bit of a magic just because it is accessible to everyone, so you can build huge, massive infrastructures, which is pretty cool. Now, for full transparency, I am not a Kubernetes expert, so I will not go deep into how Kubernetes itself works. However, the slide does show in a form of sort of a diagram the different components and solutions that StarlingX supports so that you can configure your system in a very flexible way. Like you can see that you can use Calico for networking. There are different device plugins, so you can use GPUs and FPGAs and other cool things with StarlingX, because especially in the AI world and era, we all want to depend on some special and more performing hardware options. So through a pluggable architecture that Kubernetes itself already supports, StarlingX just builds on that. And when it comes to container runtimes, StarlingX does support Kata containers, and I will shamelessly plug it in here that Kata is a secure container runtime, just because we talked about security a little bit today. So what Kata Containers does is it is creating a fusion between containers and virtual machines. So it uses a really lightweight virtual machine and puts your container inside it. So why is it cool and important for something like StarlingX? Now, that is because if you have a distributed system, and like if you think about, like for example, the telecommunications segment, and something like a site that is attached to a radio antenna, then like one server, really small footprint, so accessible to everyone physically, and in these type of deployments, if you're able to have added an added layer of isolation and isolate and separate your workloads that way, that has multiple advantages, and not just making your environment more secure, but if you think about Kubernetes and things like multi-tenancy, so if you have multiple users who are sharing the same infrastructure and you want native multi-tenancy, which Kubernetes out of the box does not support, Kata containers, if you're using Kubernetes with Kata containers, then you can implement multi-tenancy in a Kubernetes environment, distributed or not. So the two, and well, three together are giving you a very powerful infrastructure option. StarlingX has various deployment models. When it comes to the geographically, not finding my words well anymore, but I'll do my best to be understandable. So in the geographically distributed way, like if you remember the slide with the cloud icon and the sites, so currently you can have up to 5,000 sites connected to a central cloud, so it is a pretty big deployment. Later on, I will have one or two slides, I think one, that will put this number into a little bit of a perspective. And if you also remember that slide, how one site had one server, the other one had two, so that connects to the different deployment options, whether you have all the control, compute, storage functions on one server, two servers, or multiple servers, then you can ensure that you are using your available hardware resources efficiently. This is roughly schematically how it looks. So if you think back to the Kubernetes slide with the boxes of control and worker node with kubelet, then this is how it looks like from deployment perspective. So you have control nodes, you have storage nodes, and you have worker nodes. And later on, I will show how you can combine these. And this slide also shows the network architecture, which I will not go into in deep details. Not a networking expert, and if we went into this, then we would probably need multiple hours to spend on it. But what you can see is that there are isolated networks for different functions. There's an internal management network as well as a cluster host network, so that both your the control functions that make the system work have dedicated network, as well as, for example, the whole Kubernetes distributed deployment has its network, so Kubernetes can orchestrate all the containerized workloads that you have. There is a dedicated operations administration management network, OAM network as well, that goes into the cloud admin internal network. And you can connect the cluster host network to an external network also. Now, the different configuration options. You have the option to deploy StarlingX, and if you're only using it with Kubernetes, then Kubernetes on one single controller node which then has compute and storage resources in it. When you have that, you will have Ceph on that controller node along with the workers. So the control functions are sharing the hardware resources with your workloads. Now, when it comes to some use cases, sometimes you only have one server at your remote location, so you just have to figure that out. There are some ways, depending on what hardware you own and have in the server on that site, to minimize the resource footprint of the control services of StarlingX, but that is dependent on the hardware that you have. And the color of the networks here is different. I mean, same colors, different meaning than the previous slide, so don't get caught up on that one. But you see how you have the operation, admin, maintenance network on one side, and you have data networks set up to be able to connect out to the public network, because you usually just at one point will need to some parts of your system to reach the wild web out there. Now, one thing that this configuration also means that if you have a hardware failure, then you are pretty much in trouble. So there isn't really much high availability built into this one. One server is one server, even though we are talking about serverless things these days, but the serverless things are still running on servers. Sorry to break that myth. But again, if you are constrained on resources, you can run everything on one node. Now, if you have two, so again, back to the diagram with the little cloud, then if you have two servers, then you can run two nodes, so you have redundancy built into the system. You see that you have controller 0, controller 1 with compute and storage in those nodes. So it's like the all-in-one simplex configuration doubled. But what that gives you is if one fails, you can still rely on the other one. And StarlingX does have different options to configure how you are relying on that failover mechanism. And you see that this also adds additional networks to the picture, so that you have the two controller nodes connected, and you have the choice, depending on your hardware setup, whether you're directly connecting those servers or you are connecting them through a network that is more than just cables, literally physically connecting the two. When it comes to the management network, when you have the geographically distributed deployment of StarlingX, then you can also have an admin network that takes care of some of the distributed cloud synchronization functions. However, if you choose not to configure that optional network, all that will go through the management network. And what you need to know is that you have some flexibility with the admin network if you choose to have it, so that you can more easily configure and adjust that during runtime. The management network is a little less flexible to change once you have your full deployment. The standard configuration that StarlingX uses is 2 controller nodes with storage. Well, this is one of the standard options. And then you have the compute/worker nodes separately, which means you have dedicated space for the dedicated resources for the control functions, and then you have the workloads running on separate servers, and those nodes are connected to the public network through your data network or networks. Again, redundancy. So depending on the available resources you have, this one ensures that your workloads get the most amount of resources and will not be disturbed by the system functions, as little overhead as they have. And you still have, with the 2 controller nodes, the option to run those in a high availability configuration. Now, I haven't mentioned it, and it's not really depicted on any of the slides, even in this one, where you see that you have the option to utilize some of your nodes as storage nodes in a dedicated way. Again, StarlingX integrates Ceph and supports different replication profiles to use with Ceph. And you can have dedicated storage nodes. You can also use external storage devices. I think StarlingX currently supports NetApp devices and maybe Dell too. If you are with a storage company or want to use StarlingX and you have a favorite storage vendor but it's not supported yet, I would love to encourage you to come participate in the community and add support for those devices. But the point again is that with the storage nodes, you also have the option to have more than one extended amount of resources, as well as having high availability setup for your system, which can be very important even when we talk about having a configuration and microservices and being able to just spin up a new instance of whatever function and workload you have. Sometimes, in some cases, having that redundancy and failover mechanisms still come handy. So distributed cloud, because that's what is coolest about StarlingX. The functionality has been available since the 3.0 release. So that practically means that once the project was created, established, and the community was up and running and had literally a couple of initial versions of the platform available, they early on focused on creating a geographically distributed version of it. So you have a central cloud component, which again, I think it was the first diagram that I showed with the little cloud icon, and that runs a component named system controller, and your edge sites or remote sites are connected to that central cloud. And StarlingX follows the distributed control plane reference model created by the Open Infra Edge Computing Group, which means in practice that the remote sites do have autonomy. So if there is a hiccup with the connection between the central site and the remote sites, and there's no synchronization going on for a while, you can still, your remote sites will still be functioning and be able to operate without that connection in place. So that is what the distributed control plane reference architecture means in practice. The system controller holds, as kind of its name suggests, the control functions. So it does things like user management and authentication and authorization through Keystone. If you're not familiar, Keystone is the identity management service component of OpenStack. So this is one of the examples on the platform layer how the StarlingX platform utilizes components from StarlingX as well as Kubernetes to build that platform layer. The Horizon dashboard is the other example, which is another OpenStack service or component that you can use standalone, and that is what the StarlingX community is using to serve as the dashboard for the distributed system. What you can do with StarlingX in more recent releases is in a geographically distributed system, you can have things like, I don't know, a natural disaster in a region and an area which takes down your entire cluster there. So you can now implement geo-redundancy with the platform, and you can see it's a very high-level diagram in terms of like having two clusters with, again, two controllers and then the worker nodes. There's only one rectangle for workers, but it represents as many as you have. And so you have redundancy within your cluster in a region, and then that region is synchronized to another region, and you can set up different failover scenarios in case one of your cluster in its entirety goes down. And you can also obviously sort of, I think what the community uses the term rehome subclouds or remote sites from one system controller in one region to the other, so you can have the full alternative running up and running even when you lose one of these clusters. And I also want to spend a little bit of time just to run through some of those components that the StarlingX community is designing and implementing themselves. So these components are not integrated. These are the components that are created by the StarlingX community themselves. So the system has kind of a, I don't know, layered onion architecture from the services perspective. So configuration management covers things like discovering new nodes in an as automated way as possible. So the configuration management here means more of the hardware resources view of the system. So discovering nodes, discovering what kind of resources they have, how much, taking inventory, so that you can manage all that centrally within your system. Host management goes closer to actually managing those resources. Just think about the lifecycle management for the hosts/servers. So you can obviously start them up, shut them down, as well as monitor their health, whether or not the server is up and running, whether or not the resources in the server are working. And you can configure Pixie Boot, for example, in your system, and that can be something that you manage the stages, upstate or shutdown of your servers. One thing that I also want to mention that is not on this slide, that recent years there is a lot more discussion about resource consumption. So both StarlingX as well as, for example, Kubernetes and also OpenStack community, everyone is aware to look into how to minimize the footprint of these platforms and services to get closer to a greener architecture. So StarlingX, the community, they are constantly looking into utilizing those kind of improvements in the components that they integrate, as well as looking into how to build on those within the StarlingX platform as well. So when it comes to resource utilization, there are a lot of functions getting available these days in terms of things like CPU usage and profiling that and configure how the system is using the available hardware resources. Then service management covers the setup and configuration for actually managing your high availability profiles for the platform, which we talked about that it is relevant per site. So if you have more than one server, because if you only have one, you still only have one. But if you have multiple servers, and you also have obviously the geo redundancy through the distributed cloud service. But when it comes to the controller nodes and managing your cluster, there are different redundancy models that you can set up, and you can have active-active or active standby configurations as well implemented with StarlingX. I used to work in the telecommunications segment, so that is a great example of a use case where high availability configurations are still essentials. To mention an example, I I think the telecom segment still has the 5 nines availability requirement, which means that the system has to be up 99.999% of the whole year. So that means that the telecom network can have roughly 5 minutes of downtime throughout an entire year to fulfill that requirement. I'm gonna tell you it takes me more time to drink my morning coffee than that. So it's not exactly a lot if you think about like that's what you have for the entire year. So there are use cases where you need to be able to do everything to minimize the system's downtime. Fault management kind of builds into that because it's one thing to monitor the system, but you also have to be able to access what went wrong. So in the distributed system configuration, you have obviously that central view of your distributed deployment, and StarlingX does support having access to the active alarms as well as making sure you have logs within the system so that you can analyze what went wrong and how to fix that in the long run, which I think at one point probably that is something that AI will be used for, but it's not something that I've heard, for example, telecom companies adding to their networks just yet, but that will be an interesting development of the system. And this component has a REST API, as most of the other ones. It also supports SNMP if someone is old school and needs that interface to plug it into their management system. Software management takes care of things like updates and upgrades, so both patching the system, which if you have, I don't know, 500, 1,000, few thousand sites, then patching becomes a little less straightforward compared to walking over to your server, plugging in a USB drive, and then just get it done. So StarlingX is a platform that is getting more and more automated to make sure that when you need to manage a large-scale deployment, then you can do it as easily as possible. Because if you remember the slide with the controller nodes and the worker nodes and compute and a lot of boxes and a lot of lines with the network connections, and I think not all of them were on that slide either. It's a complex system. So once you have a massively distributed system, it's going to be complex no matter what you do. So the only thing you can do to make your life easier is to automate the heck out of it. That's the only way forward. So StarlingX just got a new release out. What was that, last week or something along those lines? Yeah, a week and a half ago, last Wednesday. And there are quite a few new things in the platform. One thing, interestingly, sort of, is native support for IPv4, IPv6 dual stack. So runtime, you can configure the system to go and switch between single and dual stack. Network configuration, if you are working for anyone or administering a system where you need to support these both simultaneously, I'm pretty sure that you're with me on wishing that we were past that migration stage and we would just have IPv6 finally. But in many cases, many service providers, they just need to be able to support them both simultaneously. So it is something that was a user request, and users are working with the community to get these features implemented. I talked a bit about software management. So since the project was originally created, the community was working towards unifying the interface for doing updates and upgrades. So now you have the ability to use a unified single interface to take care of all those functions. And I also mentioned the low latency kernel at the beginning-ish, well, middle, maybe 1/3 of the presentation. So StarlingX does support both a standard as well as a low latency kernel. You can now switch between the two options during runtime, so you don't need to like shut down, redeploy the system to pick that configuration option. One thing to note is low latency might sound pretty cool. So you might get tempted to use that one. It has a little higher resource utilization and resource needs than the standard kernel. So unless you have a use case that directly requires to run the low latency one, I would suggest to stick with the standard first. Now, I mentioned the telecom industry. So if you imagine a telecom network, they have a big central cloud, and they have a few more hops by the time you get to the actual antenna that your phone connects to first. And that system and deployment can be very large. The latest 5G deployments are a bit more modular than how a telecom deployment used to look like. So the radio unit out at the antenna is connecting to a distributed unit, and now the number of these radio units that are connected to a single DU, because telco companies like their acronyms, it can grow as big as 50,000. So that's a pretty big number. Like, to again put it into scale, if you need to deploy these things and you actually have to get out to the antenna sometimes, then if you deploy 100 of these as sites/sub clouds a week, then it will still take you a year. So it is big. And when it comes to these deployments, many of these sites are fully remote, so having things like zero-touch provisioning, as well as an automated way to manage these sites remotely, to do firmware upgrades and updates, patching, to have all the latest and greatest security fixes and patches is very, very important. And then I also talked about, automate things as much as you can. That applies to things like certificate management as well in the system. I mentioned the simplex configuration, so hopefully we are not having failures here, but at least you all can hear me. So the all-in-one simplex configuration, as a reminder, that is when you have one server and you have everything running on that one server. Now, if you have Intel 4th Gen Xeon processor, then you have the option to configure the StarlingX platform to use only one CPU core for the platform control services. Not bad, not bad. So the community is working on trying to make sure that the platform services are running on an as tiny resource, hardware resource footprint as possible. So further improvements are coming, both using less resources as well as scaling out the number of sites that you can connect to a single central cloud. And if you're in the telco industry, I just put up a few other things that are supported by StarlingX. The precision time protocol is something that is taking care of time synchronization within your system on a very precise level, so to say. And this one is something that both telecom operators rely on, but it is useful in many other use cases. I think I mentioned industrial automation at the beginning. That is another prime example where you would want to use something like PTP. You don't want the robotic arms to go crazy, especially if there are humans around. And the StarlingX community is working closely with the ORAN software community. ORAN as Open Radio Access Networks. If you're in the telco industry, you know this one very well. If you're not, I'm happy to chat about it a little bit after the presentation. But since we have, I think, only 10 minutes left, I'll just move forward and leave that for after the presentation. So StarlingX is an open source community, which means that you can and should get involved if you're running the project, even if you're just thinking about, trying it out. There are different communication channels that the community is using, and I swear I will replace Twitter with Blue Sky and Mastodon, because we do have those handles for StarlingX as well. So you can catch people on Matrix, which is a chat platform. The community is most active on their mailing list, StarlingX Discuss, which you can find on their lists, starlingx.io. And the community is also having a few weekly calls where you can pop in, say hi, ask questions, or just introduce yourself and get started in the community. And there is an online event that is coming up in a month, well, 29 days. It is fully online and free to attend. The event is called Project Teams Gathering. We usually just refer to it as PTG. This event is a contributor-focused event where open infra as well as adjacent communities come together, and they use the available time and space to talk about their projects, things like, release planning, retrospective, what went well in the previous release cycle, what didn't, any architectural changes or topics that need an extended amount of time to discuss. So it is all kinds of conversations that are relevant to the project. When it comes to the StarlingX community specifically, they do have project team updates, because if you remember, I was talking about the different services and components like the software management and fault management and those kind of things. Some of them have dedicated project teams within the community. So those teams come and give a brief update about what they did in the previous release cycle and what their plans are for the current or upcoming release cycle. So if you are new to the project, then it's good to pop by this event and get those project updates, because it will make it very easy for you to get a quick start in terms of what's new in the platform, what's cool to check out, and what might be relevant for you to use and rely on. You can find details on the openinfra.org/PTG website. And you can also catch me and ask questions if you have any questions about the event, or as well as the community/project afterwards. And with that, I think I spared 7-ish minutes for questions, if people have any. Yep. So I think the question was, what is the biggest deployment that StarlingX has?
Yeah, either by number of nodes or like over how big of a land mass, are these spread out? Is it global, or is it like?
So I don't have the exact numbers, and I will blame the telecom industry for that, because StarlingX is ran by companies like Verizon, Vodafone, T-Systems. So those are large telecom companies around the globe, and they are running, their 5G workloads on top of StarlingX, for example. So those numbers around the 50,000 radio units, those numbers are coming from those companies, but I don't have the exact number and the exact mapping of which company, which operator is running StarlingX in exactly what footprint. But those numbers, the telecom industry example, those are coming from those companies, as some of the contributors in the community are working with those operators, as their company is a vendor to those operators. So I grabbed those numbers from them, but it's like just the order of magnitude type of number. I hope that's helpful. Yeah, that might be long to
Okay,
repeat.
so I have a few questions about the internal architecture of StarlingX. I see that it's based on Debian, And I'm curious, are you going to sync with the almost kind of 4-year release cycle that Debian Stable does, and keep the components with what's gonna, and just basically do the kind of distribution upgrade when Debian does the distribution upgrade? Or are you maintaining like a separate layer on top?
That's a great question. I don't have the full visibility into that level of the development. I know that I think in the latest StarlingX release, the Debian version is 6.6 or something along those lines. So I'm sure that they are not sticking to the major releases only. So they are moving up with the releases as quickly as they can. And trying to avoid to stick to only the stable releases, as far as I understand. I think they also have some patches and working with the Debian community to make sure that those are upstreamed into Debian, just to implement some of the specific functions in StarlingX.
Yeah, I asked because I know right now the vast majority of OpenStack is packaged in Debian. So I guess I should have asked this first, but are you using those OpenStack packages, or are you using one of the OpenStack on Kubernetes, so, like OpenStack Helm? I've seen some of the other distributions of OpenStack use like OpenStack Helm under the hood, like Atmosphere and GenaStack did.
So there is Helm as well as Flux CD under the hood. So StarlingX does rely on those. To my knowledge, they do not use the packages in Debian. They use Helm and put the OpenStack services into containers, and that, like the entire StarlingX platform, the platform services and components, they all run in containers, including OpenStack. Both those, like the Keystone and Horizon that I mentioned, that are on the platform layer and used for control functions within StarlingX, they are in containers. And when you deploy OpenStack as a cloud platform on a site, those services are also running in containers. And to my knowledge, that happens through Helm.
Thank you.
I think there was one up here.
If a developer wanted to start developing on StarlingX, is there like a DevStack version for them to download? And for OpenStack, they have the DevStack. Oh, maybe this is something we need to request.
So, no. So the community a while ago, they were looking into trying to do, I don't know, like a virtual machine with a snapshot to have StarlingX up and running, but I don't think that exists anymore. I'm 100% sure that it doesn't. If you since StarlingX does have the all-in-one simplex configuration with everything in one node, I think that is the closest that you can start with, evaluating the platform. And I need to double check the documentation. At one point in time, it did exist so that you can deploy that in a virtual environment. I don't know if there's any specific support for that today in the current version. That's something that I need to look into. But there is an extensive documentation on the docs.starlingx.io website, and you will see the deployment options listed there, as well as an install guide, how you install those different configurations. So I wish there was a DevStack-like solution, and for those of you who not know, DevStack is a tool that you can deploy OpenStack with in kind of a proof of concept way. So if you heard about it and you think that that is something that you're going to deploy your OpenStack cloud in production with, do not do that. It is strictly for testing, and yeah, StarlingX does not have that. And with that, we are just on the dot out of time. So if you have more questions, I'll be here, and you can find me here or outside the room. And I'll just unplug and make sure that the next speaker has a chance to set up.